Solve another Leetcode problem 2672, number of adjacent elements with the same color. So for this problem, we are given an integer n and representing an array of colors. So from the beginning, all the colors are going to be on 0. And we are also given a 2D integer array queries. So the queries meaning is from index I, we're going to set a color I. And we should also know that the color gonna always be more than or equal to 1, less than or equal to 10 to the power 5. So this means the color is not equal to 0. This is important for us to understand the problem. So from the beginning, we're gonna set all the colors. So as n equal to 4, so we're gonna set an array color. So this is a color array. So the color array gonna equal to this array, and from beginning, all the colors gonna be on 0. Now, we can do such kind of two operations for each of the query. So for the i's query, we're going to set the color index to color I, and we're going to count the adjacent pairs in colors set to the same color. So the meaning is that, so from the beginning, our count is 0. So this is our output, because we have 5 queries, so we're going to set an array as our answers. So from the beginning, it is 0. Now, for the first query, we're gonna set 0 to 2. At index 0, we're gonna set it to 2. So now, what's gonna happen for us is that can we find two adjacent pairs, 2, 0, or some other pairs? Can we find two adjacent pairs with the same color? So this 0 just means no color. So we cannot compare that. So with 2, 0, there's no two adjacent numbers which have the same color, two adjacent index which have the same color. So it's going to be 0 for the first query. And then we're going to set index 1 to 2. So from here, we're going to set it to 2, and we're going to check the adjacent pairs which have which is the same color. 2 and 2, it is one pair. And now we're going to continue 3 to 1. So from here, we're going to set the index to 1. And how many pairs? It is still 1. And then we continue 1, 1. We're going to set 1, index 1 to color 1. How many pairs? No, it's going to be 0. And we're going to continue for the last. So the index 2 is going to be set to 1. So this is the index 2. We're going to set to 1. This is a pair, this is another pair, so it's going to be 2. So this is going to be the final answer. So this is just help us to understand the problem. But while we are trying to understand the problem, we're going to think about how to solve the problem. So can we use the previous calculated result to calculate for the next result? This is very important. Because basically we cannot use the brute force, because for brute force we have to check all of them. So after the first query, we're going to have a set of value, and then we're going to check the color array, and we're going to check the neighbors. So definitely it's going to be n squared. If the query's length is n and this number n is also n, it's going to be n squared. And n going to be 10 to the power 5. Definitely it didn't work. So this means we're going to use some clever way, which is similar like dynamic programming. So basically we can use the previous calculated result for calculating the next result. So the meaning is that, let's just use example. So which example I gonna use? Let me think about it. So maybe here. Let's just use this example. Currently the colors array state is like that, 2, 1, 0, 1. Because we didn't use the last query yet. So currently our result, we should know that it is 0 because there's no pairs. So if we know the previous result, so this is 0 is just the previous result. So currently I'm not talking about how to calculate the previous result, but it is just the same idea. So if we know the previous calculated result, so for this one it is 0. So what's going to be the next result? So for next result, we just check which areas is changed. Because we only change a little bit areas, it doesn't influence the whole area. It means if we change a little bit about the last index, it will not influence all the other index. It will always influence the neighbors. So if we change this 0 to 1, what influences only this part? It's the left side and it's the right side if it has. So it can only influence its left or right side. But it cannot influence others. For example, this number 2, it cannot influence that. So this means we can use the previous calculated result to calculate the current result. So the previous calculated result is 0. Now, before we calculate the current state, we just check from here. This 0 to 1, it is a count. It is 1. 0 to 1, we just need to check this count. As this pair 0 to 1, the color is different. And this 0 to 1, the color is different. So our count is 0. Now, we're going to change it. We're going to change this 0 to 1. And we're going to still count it. This is 1 to 1. Oh, so the count is 1. This 1 to 1, so the count is 2. So this means our new count is 2. So what is the increase of the value? It's going to be this 2 minus 0. This means our final result is going to be increased by 2 minus 0, which is going to be 2. And then we're going to plus the previous result, which is 0. So this means for the next result, it's going to be 2. So this is why here is 2. And similarly, for the first result from the beginning, we're going to always calculate it like this. We're going to always calculate the previous result, and for the current result, we just need to plus the previous result. Yeah, we just check, oh, so for the final values, it is an increase or decrease. And for that value, we just need to plus the previous result. Yeah, now let me just start coding. Actually, coding is going to be much easier. So first of all, let's just prepare a colors array. So for the colors array, it's going to be 0 times n colors. And the final result going to be 0 times the length of the queries. And let me prepare a previous state. So this previous state is just the previous sum of all the values. I'm going to set it to 0. Now, I will check the queries one by one and find the final result. So for I, let's just use AB maybe. Enumerate the queries. So what are we going to do for each of the query? As I said before, first of all, we just want to check what is the previous state if we didn't set the colors. So currently for the first query, what if we didn't set it? What's going to happen for us? We just need to prepare a counter. So we're going to prepare a count maybe, yeah, maybe it's just count. So we're going to prepare a count to be 0. Now, we just need to check its neighbors. So the neighbors, we just need to use a check. So if a minus 1 more than equal to 0, and colors a minus 1 equal to colors a and not equal to, yeah, because it's definitely the value cannot equal to 0. So this is just, yeah, we can write it in one line. That is sounds okay. So if this one equal to this one and not equal to 0, so this means from the previous state, this is the count is valid. We just need to plus 1. Yeah, and similarly we can just copy the code and change a little bit. So here we're going to use a plus 1 is less than n, and the colors a plus 1 equal to colors a and not equal to 0. We're going to update the counter. Yeah. Now what are we going to do? We're going to set it. So before, let's just set it. So the colors a gonna equal to b. So after setting, we're gonna change. Let's just copy and paste the code and change a little bit to find the result. So here we're gonna use a counter 2. So if this is also valid, so the count 2 gonna update. We're gonna update the count 2. Yeah, this is just the same idea. So this is just before what we're gonna do it. This is what is after we're gonna do it. Or maybe you can just write a function. Maybe we can save a little bit of lines of code, but I think basically it is okay. Yeah. So if you want to write a function, it is still okay. Yeah. We just need to. We just need to write think a little bit, and we can write a function to prepare on the similar code, because basically this is similar and this is also similar. Yeah. So what about the result I? So the result I gonna equal to, as I said before, count 2 minus count and plus the previous result. And after that, we just need to prepare what is going to be the previous result. It's going to be result I. Yeah. So we just need to use the previous result calculated for the current result. So this is a basic pattern for the problem. So finally, we just need to return the result array. Now let me just run it to check if it works. Oh, it didn't. Yeah. It passed for second testing cases, but for the first it didn't. I think I must made a mistake somewhere, but I don't know. Let me just check about it. If a minus 1 more than or equal to 0, yeah, I made a mistake from here. So if a plus 1 should be less than n, yeah, and here a minus 1 and a plus 1 should be not less than 0, it should be less than n, otherwise we will never check. Yeah. Now let me just run it. Now as you can see, it works, and let me just submit it. Now as you can see, it passed for all testing cases, and it's pretty fast, and the time and space complexity gonna be O(n), and n gonna be 10 to the power 5. Yeah, because we think the queries, so how many queries? Queries is also 10 to the power 5, so actually it's n plus m. Yeah, so m gonna be the query's length, and n gonna be this number. So this gonna be the time complexity, and also for the space complexity. I think that's all about it. Thanks for watching. See you next time.